how to identify and graph linear functions and linear equations. A graph represents a function if it passes the vertical line test. A linear function forms a straight line when graphed. So for the 6 graphs below, they want us to look at each one and determine whether it's a function or not, and then decide if it's linear or not. So let's look at A. Here's your graph, okay, right there. If I draw a vertical line through it, how many times does it pass through it? Once, which means it passes a vertical line test, which means it is a function. Is it also a linear function? Yes, that is a straight line. So that's a linear function. Alright, graph B. If I do the vertical line test on it, does it cross more than once? Where? No. Okay, so yes, it's a function, but no, it is not linear. It's quadratic, and we'll talk about what that means in a second. Okay, for graph C, does it pass the vertical line test? Yes, no matter where I draw a vertical line, it only hits it once, which means it is a function. Is it a linear function? No. Okay, linear functions are always y equals mx plus b, correct? Well, isn't that x always to the first power? I mean, you don't actually see the exponent of 1, but isn't it understood to be a 1 in the exponent place? Parabolas, which is what a U-shaped graph is called, are quadratic functions, and they occur when the x has been squared. And then this graph is known as a cubic function, and it occurs when the graph has been cubed. Okay, I'll show you on the calculator. Y equals, if I just have x, y equals x. Isn't that y equals mx plus b form? Your m is 1, there's an understood 1 in the m place, and your b is plus 0. You just don't have to write those things. When I graph it, I see a straight line. Okay? If I go and I make that x squared, I now have a quadratic function which makes a parabola, a U-shaped graph. If I make the x cubed, it makes a snake-looking graph, which is known as a cubic function. Okay? Alright. Graph D. Is graph D a function? Yes. It only crosses in one place. Is it a linear function? Yes. That's a straight line that's been graphed. Okay. Graph E. Is it a function? Yes. It only hits it once. I know, but it's still a function, because to be a function you must pass the vertical line test. When I draw a vertical line through it, didn't it hit it once right there? Is it going to hit it again? No. How could it? Where else would it hit it again? It doesn't come down here. Okay, so yes, it's a function. Is it a linear function? Yes, guys, that's a straight line. It's just a linear function with what?
Zero slope.
It's not making me laugh. It's a linear function with 0 slope. Very good. Okay, and then graph F. Is it a function? No, because it hits it once, and then as it continues, it hits it twice. So no, it's not a function, and no, it's not linear. It's quadratic. Okay? Alright, in a linear function, a constant change in x corresponds to a constant change in y. They want to know, are the following tables linear? A, B, C, and D. Now, obviously A and B are written in table form. C and D, instead of writing it as a table, they've listed it as a set of ordered pairs. So we're going to go one at a time. So this is like 4 separate questions, and determine whether they're linear or not, whether they have a constant rate of change. Okay, well, let's look at A first. What's happening in the table each time you go in the X column? You're going up by 1. Is that consistent? Yes. From 0 to 1 is plus 1. Pay attention. From 1 to 2 is plus 1. Now, your X is also known as your run, correct? Because what you run left and right like the X-axis. Now let's look at the Y's. First you go down 3, but then down 1, then up 1, and then up 3. It is a pattern, but is it linear? No. So this one is not linear. We're not there yet. Okay, and the reason it's not linear is because we were able to find a pattern for the x values, but not for the y values. Okay, now, if you're not good at doing it like that, another thing that you could do that you would think would be a lot of work, but it's really pretty quick, is you could just do a quick sketch. Okay, watch how quick I can do this. Negative 2, 6 would be about here. Negative 1, 3 would be left 1, up 3. 0, 2 would be up 2. 1, 3 would be right 1, up 3. And 2, 6 would be right 2, up 6. Does that form a straight line? No, it forms a V-shaped graph, correct? So that also confirms for me that it is not linear. So if you're having trouble looking at the data like this, just quickly plot those 5 points on a graph that you yourself make and see if it forms a line. Okay? Now let's look at B. From here to here, what's happening? Up 1, and then from negative 1 to 0, from 0 to 1, and from 1 to 2. Okay, so all of the x values, which are your run, are going up 1. Now your y values, which is your rise, because you rise up and down, are all doing what? They're all going down by 3. Okay, 1 minus 3 is negative 2. Negative 2 minus 3 is negative 5. So wouldn't that be a slope of negative 3 over 1? Because you always put your rise over your run. Now let's confirm that that is indeed the slope by picking 2 points. Okay, so if I pick those 2 points, not that you have to do all this for every problem, I'm just showing you multiple ways to figure out if it's linear. 4 minus 7 is negative 3. Negative 1 minus negative 2 is like negative 1 plus 2, correct? Which is positive 1. See how I got the same slope when I did 2 points as I did when I looked at the pattern? Now look, say that I decide I want to do the slope of these 2 points, which are 1, negative 2, and 2, negative 5. y2 minus y1 would be negative 5 minus negative 2, and negative 5 plus 2 is negative 3, correct? 2 minus 1 is 1. See how no matter which set of points we pick, we got the same slope for both of them? That confirms it's linear. Also, you could graph those 5 points quickly. I'm just going to do them in a different color over here to save time. Pay attention. Negative 2, 7 would be left 2, up 7. Negative 1, 4 would be left 1, up 4. 0, 1 would be right here. 1, negative 2 would be right 1, down 2. And 2, negative 5 would be right 2, down 5. Doesn't that look like a line? So that's another way. So this one is linear. Okay, now I want you to take a second and figure out C and D. Alright, the first thing I'm going to do for C is I'm going to start by taking the slope of these 2 points. And then I'm going to take the slope of these 2 points. And I'm going to see if I get the same thing. So if I'm looking at these 2 points, wouldn't that be 4 minus 5 over 5 minus 3? And that gives me a negative 1 over 2 for my slope. Now let's see if I get that same slope when I do 2 other points. 1 minus 2 over 11 minus 9. Doesn't that still give me negative 1 over 2? So that's one way to confirm that this is linear. Yeah, you could put it back in a table if that helps you. Okay, but you don't really have to unless you just really feel like it helps you, because you can still look for the pattern. Like if I look at all the x's, from this x to the next x, what happened? Right, and then from this x to this x to this x. So wouldn't that make your run 2? And then the y's, what's going on from each y value? They're going down by 1, so wouldn't that make your rise negative 1, which is what we got when we did the slope formula 2 different times? And then, of course, the other way is graph it. See if it makes a line, okay? So that was linear. What about D? Or is there a pattern in the x's? What are the x's doing? So the run is 2 because each time they're going up by 2. But is there a pattern in the y's? No. So you wouldn't know what number to plug in here because it's not linear. Yes, it is. Okay, turn to page 11. Okay, now we're going to decide which functions are linear when they're given to us in equation form. So, A, raise your hand if you think it's linear. Okay, raise your hand if you think it's not linear. Okay, well, to be linear, doesn't that mean that it forms a line, which means you should be able to get it in this form? So why don't we try to get it in that form? Okay, instead of doing that, let's remember a property that we talked about last semester. Right, which is the symmetric property. We can just put 2y plus 4 on this side and x on this side, and that helps us by putting the y where it should go and the x where it should go, correct? And now to get y by itself, we... Correct. And then we... And so y equals, isn't that an understood 1 right there? So 1/2 x, because that's an understood 1 in the numerator, 2's in the denominator, and then minus 2. So now it's obvious that it's linear, right? So we're going to circle it, because it says circle the ones that are linear. Okay, write all of that. I'll give you time to catch up. Do you think it's linear? Okay, well, let's talk about if we tried to attempt to put it in y equals mx plus b form, how would you get this y by itself? Well, no, you have to divide by x because they're touching, which means they're being multiplied. So wouldn't that then leave you with y equals 4 over x? Does that look like y equals mx plus b form? No. You cannot have x in the denominator. If you have x in the denominator, it's not a linear function. It's what we call a rational function. And let me show you what it would look like if you graphed it. If you're ever having trouble, you just need to graph these and see what they look like to know if they're linear or not. What? Okay. You go to y equals, which is what I just pressed, and then you just type it in, 4 over x. So 4 divided by x. And then hit graph. Does that look like a linear function? No. Y equals, and then you type it. So like this first one, 1/2 x minus 2. Graph. Okay, so what about C? Do you think it's linear or not? Why? Right, the only thing you have to do is what? Okay, so it'll become y equals negative 7x minus 9. You just end up having to combine that 5x and 12x. It's like there were 2 mx's, so they had to combine together. So this one's linear, so we'll circle it. Okay, D, is that linear? You don't think so? What if I wrote this? Would you tell me that this is linear? Is that not the same thing as that? Yes, think about it. You just didn't have to write the 0x because of its 0, and then that 12 is your B. It just got slid over because the 0x didn't have to be written. This is what it would look like, okay? Stop and pay attention a second. Y equals 12. Graph. Any ideas why I'm not seeing the graph? Well, because the graph doesn't go up 12. Okay, now let me show you how to change that. Pay attention. This will be useful to you for the rest of high school and college. What you're looking at is called the window. This is the window. So if I want to change it, it currently is 10 that way, 10 10 that way, 10 that way, and 10 that way. Well, I obviously need to see up 12 because it said y equals 12. So I go to window, and then y max, I want to go higher on the y-axis. So I go down to y max, and I'm going to put it to like 15. And then when I hit graph, now it goes up 15 units, so now I can see where y equals 12 has been graphed. Isn't it just 12 is the y-intercept, and then the slope is 0, so that's why it's a horizontal line? So it's linear. So we circle it. What about E? Is that linear? No. You cannot have x as the exponent. Okay? You can't have x as the exponent in a linear. I'll show you what it looks like on the graph. Y equals 2 to the x power. 2 raised to the x power. That doesn't look linear, right? That's what we call an exponential function, and the reason it's exponential is because the x is the exponent. So exponential is the exponent. Okay, moving on. Tell whether the function is linear. If so, graph the function. Is y equals 5x minus 9 linear? Yes, it is. And they want you to graph it, but using a table. So you're going to use that y equals 5x minus 9. But what kind of information have they given you? X values to plug in. So like in the first time, instead of x, they want you to plug in a 0. And when you plug in a 0 for x, what does it give you for y? Think again. Negative 9. Because 5 times 0 is 0, but 0 minus 9 is negative 9. Okay, then the next time they give you a 1. So they want you to plug in 1 for x. And so when you plug in a 1 for x, what do you get for your y value? Negative 4. 5 minus 9 is negative 4. And then in the next one, they want you to plug in a 2 for x. Right. 10 minus 9 is 1. So what you've created here is 3 points that you can plot. 0, negative 9 is just down 9. That's your y-intercept. 1, negative 4 is just right 1, down 4. And 2, positive 1 is right 2, up 1. You have your 3 points. You can now connect them, and you are done. I want you to try the second example. Yes, you're going to have to rewrite that into slope-intercept form first. Let's go and go over it. So the first thing you had to do was you had to rewrite this into slope-intercept form. That only required you to move the 3x to the other side, making it negative 3x. Then they gave you 3 different x values to plug in for the x place. And when you do that, an input of negative 2 gives you an output of, an input of negative 1 gives you an output of negative 1, and then an input of 0 gives you an output of negative 4. Then you plot those points, so negative 2 up 2, negative 1 down 1, and then 0, negative 4. Why is that line going down? Correct. Which line, the left one or the right one, is steeper? The left one. It's probably a little hard to see because maybe I didn't slant mine just right. You see how it could have really gone through that point better and that point better? Let's talk about why this one's steeper. What was the slope of this one? What was the slope of this one? Okay, well, let's just ignore the negative for a second because that really just determined that it went down, correct? So we'll just say 3. Which number is the bigger number? 5, which is why that's the steeper line. Okay, the bigger your slope value, the steeper the line. Okay, next page. Now we're going to learn how to find intercepts and interpret their meanings in real-world situations. Graph the line and identify the x and y intercepts. Well, before we can graph A's equation, what do we have to do first? Correct. So, Samantha, tell me the first thing to do. So then what will that become? Almost. Negative 5x plus 15. Okay, then what do we do? Not yet. Y is not by itself yet. You got to divide. Because, yeah, they're touching, which is multiplication, so you have to divide. And so we're left with y equals negative 5 over 3x plus 5. That gives you a slope of and a y-intercept of 5. Okay, so when you graph that, what do you do first? Okay, so 1, 2, 3, 4, 5. And then from there, the slope tells you to go. Okay, what is the definition of a y-intercept? And what do you know about the x value when that happens? What's the x value of your y-intercept every time? 0. Otherwise, it wouldn't be a y-intercept. So what's the definition of an x-intercept? Where it crosses the x-axis and its y value would be 0. Okay, so I'm going to first connect these with a line, and then we'll identify the x and y-intercepts. Okay, we've already spotted them on the graph. Here's your y-intercept, here's your x-intercept. Now we just need to write down the coordinates of them. Okay, what are the coordinates of the y-intercept? The x-intercept. 3, 0. Because remember, this is your x value, this is your y value. Don't you have to go right 3 on the x-axis to get to it? And then what are the coordinates of your y-intercept? 0, 5. Remember when we were doing tables and we were finding y-intercepts and I told you look for where x is 0? Well, when you're finding x-intercepts, you look for where y is 0. Well, the x-intercept is where the line hits the x-axis. The y-intercept is where it hits the y-axis.
So all we're doing is rewriting common and then finding the y.
Yep, that's it. Okay, now let's look at B. How would you rewrite it? Correct. You just have to, since it won't simplify to a whole number, you just leave it 2 over 5. And then your y-intercept becomes 10 over 5, which will reduce to 2. So for this one, your slope is, and your y-intercept is 2. So when graphing it, what do you do first? No, you always do your y-intercept first. So you, up 2, and then from there, the slope tells you how to get to the next point, and the slope tells you to go. No, it's positive. It was negative. When you moved it over to this side, it became positive. Okay, but now look, if I continue going up 2 over 5, am I going to find the x-intercept? Correct. Instead of going up to right 5, I should do the opposite and go down to left 5. And now haven't I identified the x and the y-intercept? Okay, so now I just write the coordinates of them. Yes? Okay, so now x-intercept. What are the coordinates of the x-intercept? Negative 5, 0. Because you have to go left 5 on the x-axis and then you don't move anywhere on the y, so it's 0. What are the coordinates of the y-intercept? 0, 2. Okay, I want you to try C and D. However, C is ugly. So I'm going to change it. I want you to do this equation instead. 2x minus 8y equals 8. So be trying C and D. For this one, the first thing you would have done is subtracted your mx to the other side. So we're subtracting 2x to the other side. Shh, sit down. Now negative 2x plus 8. So now I divide by negative 8, divide by negative 8, divide by negative 8. That becomes y equals, okay, let's talk about some things. Negative over negative is positive. So even if you leave it 2 over 8, I'm going to show you what will happen. Okay? But you should definitely simplify the negative over a negative to a positive 2 over 8. 8 over negative 8 over negative 8 will become a negative 1. So everybody look up at the board for a second. My m currently is 2 over 8. My b is negative 1. So if I plot my y-intercept at negative 1, and then I go up 2 over 8, or if I had gone down 2, back 8, it kind of makes it hard for me to find the x and y-intercept, right? So maybe it would have been easier for you had you simplified this to 1, 4. Because then if you went up 1, right 1, 2, 3, 4, then, oh wait, that's only 3 over, isn't it? Hold on. 1, 2, 3, 4. Now look, it makes it a little easier to see where it hits the x. You already know where it hits the y. Does that make sense? Okay, so connect your points. Right, the other way might make it a little harder to find where it hits the x-axis. Simplifying is always best. So what are the coordinates of the x-intercept?
4, 0.
And what are the coordinates of the y-intercept? 0, negative 1. Okay, be working on D. And also get out your pink sheet.